Hello, I'm Hugh Manfield, and welcome back to the Fluid Space Theory lectures. Now today we're going to go into a little more detail with something I call the old news aberration. And if you're interested in learning more, you can always pick up a copy of my book, Einstein and Aliens, A New Approach to General Relativity, and all the math and reasoning is worked out in the appendices, and there's a nice science fiction adventure for those of you who don't want to learn the math. The next subject we need to understand is the old news aberration. And I call it an aberration because it can make you see things that aren't really there, and you have to correct for them to understand what's actually going on. So how does it work? Well, you have to understand that all objects are separated by some small distance. Even across an atom or a molecule, there's a distance, and there's an amount of time that it takes, the speed of light, to move across that distance. Now, at microscopic scales, the time frame gets very, very short, so things happen almost instantaneously. And from our point of view, between Ricky and Stan, if they're talking by radio, there's no delay really to notice when they talk to each other over that short distance. Now, if Ricky was going to talk to someone on the moon, it might be a second or 2 light seconds away, so there would be a noticeable delay in the conversation. And it gets increasingly greater with distance. The light from the sun that Ricky sees could be about 8 minutes old. That's how it is here on Earth. The light we see from the sun actually left the sun about 8 minutes ago. The light we see from a distant star could be thousands of years old. And the light we see from a distant galaxy could be millions of years old. So the old news aberration increases with distance and is always there. And we have to account for it in what we're looking at. And I can explain that better once we understand how these charts work. Now, when we're talking about things in space and time, we have to realize that there are 2 different types of objects. There are objects and there are events. 2 different things. Now, objects are stuck on the now line. So if we had a bunch of clocks laid out and spread out in space, they all exist now. And that now is constantly moving into the future. So they're all stuck on the now line. Now, if those clocks are ticking, the ticks are events. And an event is frozen in time. So with each tick of the clock, it passes farther and farther into the past. So events fall into the past while objects remain on the now line and move into the future. So the old news aberration comes about when the clocks are spread out and you're a long distance away from another clock. You won't see the tick of that clock or hear the tick of that clock for a delayed time. So you're always looking at an after image of what that clock says. So if all these clocks are synchronized and you look at that clock, you would say, no, they're not synchronized. This clock is slower than my clock. It's behind. But it's not behind as much as this one, and the closer the clocks get, the closer they appear to be synchronized. But in reality, they are all synchronized, but the old news aberration lets you see something that's not true. You see them not being synchronized. So another way to understand what the old news aberration does with reference frames is to imagine a row of rockets. Now on the bottom line, all the rockets are sitting on the launch pad and they haven't fired their engines. Now they're identical rockets, they have the same thrust, and they're programmed to all launch at the same instant. So when that happens, if you're riding on any of the rockets, you will see what's going on with this blue rocket. Let's say it's traveled for 1 second and the rockets are 1 light second apart. And I've scrunched them in so they can all fit on the same chart. So what you will see looking out the window at 1 second is that the neighboring rockets, which are 1 light second away, are still on the launch pad. It's a delayed image. It's old news. You're seeing that rocket where it was 1 second ago. So at 1 second, you'll see the rockets fire and begin to move. So at 2 seconds, when you look out, you'll see rocket's 2 light seconds away, still on the launch pad. You'll see the rocket 1 light second away has moved the same distance you moved in the first second, but now you're in the second and you've moved even farther, and so on and so on. So what you will see from the rocket is that the planes are not remaining plane, the rockets are not staying in a straight line, and all the other rockets are falling behind you. But that's not what's really going on. What's actually going on, as long as there haven't been any mechanical failures, all the rockets should be firing at the same rate and traveling in a straight line together. And you can correct for this because you can look at the fourth rocket and say, you know, that image is 4 seconds old. So if it actually fired its rocket the same rate that my rocket fired, and 4 seconds have passed, 1, 2, 3, 4, it should be tracking along in parallel with me. So you have to track the objects and use math to correct for the old news aberration, because it's going to show you something that's not actually happening. And if you don't understand this, you may make some faulty conclusions. You may conclude that the space-time of your accelerated reference frame is actually warping when it's not. So if we go back to our grid work of rods and clocks, and in this time we put a force on that grid somewhere or multiple forces so that it accelerates in a line at a constant acceleration. From any point of view of any clock, you will see yourself, if you're on that clock, you'll see your clock start to move first, followed by the clocks going progressively outward. So the whole framework will begin to appear distorted and the clocks will appear to be unsynchronized. But what's really going on, if you account for the old news aberration, is that the rods and clocks are actually still synchronized. The planes are straight, the rods are straight. All you have to do is account for the old news aberration. So, not accounting for the old news aberration has led to some mistaken concepts being handed down in physics, and even by Einstein himself. So now we're ready to move on to more interesting subjects of fluid space theory, including how fluid space theory contains the dark matter signature.